Guys, if you're watching this, that means that you think that you need some work on acids and bases. Absolutely fine. Okay, so let's go through the acids and bases topic. I imagine some people might want to go over titration calculations. Um, I will very briefly touch on them. However, if you get to a question on titration calculations, I am more likely to go on to a live Teams meet. I'll start one just to go over titration calculations, because it's easier doing it using all the other tech that I have rather than going through a PowerPoint. Okay, so keep that in mind. So let's look at acids and bases. So pH scale measures the hydrogen ion concentration. So the lower the number, the higher the hydrogen ion concentration. Water is neutral, as water can dissociate from H2O into H plus and OH minus. Because that happens at the same time, in pure water, there is equal numbers of H and OH, hydrogen ions and hydroxide ions, okay? There's only ever a few water molecules dissociated at the same time. So most of the water molecules will be as H2O. Remember, this symbol means the reaction goes forward and it goes backwards. So H2O can break up into H plus and OH minus, and OH minus and H plus can come back together to form H2O. Okay. Neutral solutions have an equal concentration of hydrogen and OH, and that's the pH 7. Acidic has more hydrogen ions, and it has a pH of less than 7. Remember, it doesn't just have hydrogen ions. It has more hydrogen than hydroxide ions. Alkaline is the opposite. It has more hydroxide than hydrogen ions, pH higher than 7. Okay. Diluting an acid decreases concentration of H plus and increases pH towards 7. And diluting an alkali decreases concentration of OH minus and decreases pH towards 7. And just a quick note, remember, to make an acid and a base, to make an acid, you dissolve a soluble non-metal oxide. So things like carbon dioxide will dissolve to form carbonic acid. Nitrogen oxide will form nitric acid. And a soluble metal oxide will dissolve in water to form alkalis. Okay, so sodium oxide will form sodium hydroxide. Okay. A base is a substance which neutralizes an acid. So metal oxides, metal hydroxides, metal carbonates, and ammonia are bases. Those are your, there's one missing. What about reactive metals? Reactive metals can also be a base, okay? Remember that a base is anything that neutralizes an acid. Alkalis are simply bases that can dissolve in water, and they have been dissolved in water to form a hydroxide, okay? Neutralization is when a base reacts with an acid to form salt, okay? And most of the time it's going to form water as well. So metal oxide and acid is salt and water. Metal hydroxide and acid is salt and water. Metal carbonate and acid is salt water and carbon dioxide. The carbon dioxide comes from the fact that there's carbon here that needs to go somewhere. It can't just go nowhere. So carbon dioxide is produced as well. Salts are named from the acid and base. So the first part of the name is from the metal. So if you're using sodium oxide, the salt will start with sodium. And the second part comes from the acid. So if you've got sodium oxide and hydrochloric acid, it'll become sodium chloride as your salt, etc. Sulfuric becomes a sulfate salt, nitric acid becomes a nitrate salt. Remember that spectator ions are ions that remain unchanged by the reaction. If they are in the equation before the reaction, the exact same way as they are after the reaction, they've not really taken part in the chemical reaction. They have helped the reaction happen, but they've not actually done a chemical reaction, therefore they're spectator ions. And to work out the actual chemical reaction going on, we can remove them. Once we do that, we can then write all the neutralization equations without spectator ions. So a metal oxide would be 2H plus 2O plus O2 minus would give you H2O, etc., etc. Okay. Titration. So remember, titration can be used to determine the concentration of an acid or base by accurately measuring the volumes used in the neutralization reaction. An indicator is added to show the end point of the reaction. In acids and bases, that tends to be phenolphthalein, which is colourless and turns pink when the reaction is done. Volumes within 0.2 are concordant. That means that those are the only volumes that we're going to use in our calculation. Remember, in order to get a really accurate result, we need concordant results, and that's within 0.2 centimeters cubed. Titrations of accurately known concentration. Use solutions of accurately known concentration known as standard solutions. Okay. How to make a salt. Remember that when you're making a salt using a soluble base, you can find out how much of one is needed to fully neutralize the other using a titration, and then repeat the reaction with a indicator and evaporate to dryness. Using an insoluble base, if you add the base to the acid until no more dissolves, and then filter out the excess base, evaporate to dryness, you'll be left with the salt. Okay, so the only extra thing that you would need to know is titration calculations. You have your notes, you have your workbooks, so please use them. If you're still confused and you want me to go over it, let me know. I will start a live Teams meeting just to go over that topic, that part, titration calculations. Okay, keep an eye out in the Teams. I may start at any point once you've asked. Okay, thank you guys. Feel free to go on and do the mind map questions now. And then if you finish that and you've marked it and there's no questions, go on and do some past paper questions. Okay, thank you guys.